Okay, so now in this video, we want to prove another theorem about compositions of functions. So in this, we're going to look at compositions of surjective functions. So again, assume A, B, and C are sets, and G from A to B is surjective, and F from B to C surjective. Then F goes with G is surjective. Okay, good. So let's prove this. Okay, so to show that F composed with G is surjective, we must show that for any C in C, because remember C is the codomain, there exists an A in A, so that F composed with G of A is equal to C. So every value in the codomain is hit by something, an image of something under the map from the domain. So choose some little c in big C. And again, we're just going to peel back the surjectivity of both maps, right? And since F from B to C is surjective, there exists a B in B so that F of B equals C. That's just what it means to be surjective, right? F is surjective. C is some value in its codomain, so there must be something in the domain, which is B in this case, that maps onto it under F. Good. Okay, now we got to peel back the surjectivity of G, right? So then, since G from A to B is surjective, there exists an A in A, so that G of A equals B. Okay, this implies that C is equal to F of B, as we said before, which is equal to F of G of A as desired. And that's it. So that means the composition is a surjection. Now, we've shown that the composition of injective functions is injective. We saw that the composition of surjective functions is surjective. So now we get a corollary right away that I won't do a separate video on because it's going to be very quick. Assume A, B, and C are sets, and G from A to B is a bijective. And F from B to C bijective. Then F composed with G is a bijection. Great. So not surprising now that we've seen the two previous theorems, but it's just worth writing down as a corollary, and then we'll write down the extremely short proof. So by theorem 8.13, sorry, 8.13, F composed with G is an injection, and by theorem 8.14, F composed with G is a surjection, since both F and G are injections and surjections. So then thus, by definition, composed with G is a bijection, right? Because it's both an injection and a surjection. Okay, great. So now we've played around with these various things, and now we can ask questions like, what if only one of them is an injection? Is it possible for the composition to be injection, or can we say anything intelligible about it? And the other thing we can play around a little bit with is looking for inverse functions.